Okay, in the next example we are going to solve the initial value problem. So it means that not only we have a differential equation, but we also have the initial condition. So let's see how it changes the method. Okay. So the first thing to do is we still have to separate the dependent variable from the independent variable. So we are going to multiply the whole thing by y squared and by dx. So then the left hand side becomes y squared dy, and the right hand side becomes 4x cubed plus 1 dx. Then we should introduce the integration. Alright, now y squared dy. The integral of y squared is y cubed over 3. The integral of 4x cubed is x to the 4. The integral of 1 is x, and plus constant. Alright, now, strictly speaking, we could continue and solve for y, but it is much more convenient, and sometimes it is actually even necessary to find the constant now. So notice that since we have our initial condition, and generally speaking, differential equations have infinitely many solutions. So which means that every solution of every differential equation is going to have some kind of arbitrary parameter. So here we have this plus constant. But since we also have the initial condition, it means that it allows us to solve for this constant. And so this initial condition is what we can use to find the value of c. Right? So we're going to substitute the value of y and x from the initial condition into this equation. Right? So our y is 3, so we get 3 cubed over 3, that's the left hand side, equals 2 to the 4 plus 2, x equals 2, plus constant. Right? Now 3 cubed over 3 is 3 squared, which is 9. And 2 to the 4 is 16, plus 2 is 18, plus constant, and hence our constant is 9 minus 18 minus 9. Alright, so now we just need to substitute 9 as the constant, and then we solve for y. Right, so let me do it together at the same time. So solving for y, we get y cubed equals 3x to the 4. So let me write, so now I'm writing y cubed, so I'm going to write 3x to the 4 plus 3x plus 3 times the constant. The constant is minus 9, so the 3 times minus 9 is minus 27. That's y cubed. But now y itself is, of course, going to be the cube root of its own cube, so I should write to the power 1/3. However, it is not over yet. So let me, I have to continue. So let me write that the solution that we got is that y equals 3x to the 4 plus 3x minus 27. Everything is to the power 1/3. Notice the following. Notice that we're dividing by y squared. And since we're dividing by y squared, it means that y is not allowed to be equal to 0. And yet, if you look at this expression, y equals 3x to the 4 plus 3x minus 27, there is nothing that stops it from being equal to 0. It means that we're not done yet. So not only we need to produce the formula for y, but we also need to specify on which interval it works. Let me explain what I mean. So let me draw plot the graph of this function. So I'll go to web browser. So then I'll get this very nice graphing calculator, desmos.com. By the way, you'll be allowed to use it on your midterm test. So you can just forget about your old graphing calculators, at least for this course. So let me write 3x to the 4 plus 3x minus 27 to the power 1/3. Right, so if we just plot this function as the whole thing, if we just don't bother with it being positive or negative, then we'll get this picture. But remember that in the original differential equation, we're not allowed to have y being equal to 0. And the reason is very simple. If you look at the 2 points where y equals to 0, then you will see that the tangent line to the graph of the function at these 2 points is precisely vertical. So which means that dy dt is undefined. So we cannot really substitute it to the differential equation. Well, but if y is not 0, it means that y is either positive or negative. And since the point that we have, the initial condition tells us that y of 2 equals 3, it means that y has to be positive, and which really means that sorry. So let me try to plot it now. Okay, so which really means that we should look at either of these two branches of the function, but since, again, according to the initial condition, the initial value of x is also positive, I should also write that it is actually both x and y should be positive. So let me so it is something like this. Now this point, the intercept of this function, so the point at which 3x to the 4 plus 3x minus 27 is exactly 4, from Desmos calculator we can see that it is approximately, wow, it's hard to tell. Maybe let me do it like this. Something like 1.65, whatever. So in order to find it more precisely, we can use Wolfram alpha. Right, so let us just solve the equation. X to the 4 plus x minus 9 is 0. So that's the point we are looking at. So it is approximately 1.6467. So which means where x is bigger than 1.6467 approximately. Well, by the way, if you want to find the precise value here, it is possible since the equation is quartic, it's of degree 4, theoretically it is solvable, but the exact answer is kind of scary. So here is the exact answer, the exact value of this number.